In level 2, we're going to be finding the distance and midpoint of a line segment in the coordinate plane. So back in level 1, we were only looking at a number line. Now we are working in the whole coordinate plane. So in this example, first we're asked to plot the points -2, 5, and 3, 0. So -2, 5 would be right here, and 3, 0 would be to the right 3, up or down 0. And that's my line segment. Next, we're going to find the midpoint of that line segment using the midpoint formula. And the midpoint formula is up here. The way it works is you add together your x's from 2 points, and you divide by 2, which is actually finding the average of the 2 x's, or the x that's right in the middle. And then you add together your 2 y's and divide by 2, which is the average of the y's from your 2 points. So if we look at our 2 points, we label the coordinates x1, y1, and x2, y2. So to find the midpoint, I take my x coordinates from each point and I add them together, then divide by 2, and then I take the y coordinates, add them together, and divide by 2. Now I'm going to simplify that. For the x's, -2 plus 3 was 1 over 2, or 1/2, and for the y's, 5 plus 0 is 5 over 2, and that can't be simplified anymore, but I could write it as a decimal if I wanted. So I could either have 1/2 5 over 2, or I could say 0.5, 2.5. Either would be fine. Now, if I wanted to plot that point on my graph, over 1/2 up 2.5 would be about right here. I didn't draw that very well, but you see it's right in the middle of your line segment. So that midpoint formula does find the point that's right in between 2 other points. Okay, the next formula that we're going to be using is called the distance formula. The distance formula finds the length of a line segment, or how long it is. So I'm going to kind of do it the same way. I still use my x1 and y1. I start with a giant square root, and then in my first set of parentheses I subtract the x values. So I take the first x minus the second x, -2 minus 3. Then I square that, I put a plus sign, and I do another set of parentheses, and I subtract the y values. So the y values were 5 and 0, so 5 minus 0 squared. And then I simplify. To simplify this, I do what's inside parentheses first. So I'm going to rewrite this. -2 minus 3 is -5 squared. And 5 minus 0 is 5 squared. Add those together, and, well, -5 squared is positive 25. 5 squared is positive 25. Add them together, you get radical 50. And then we just have to simplify that radical. So square root of 50, 50 is 25 times 2, which is 5 times 5. So I can take out a 5 and leave a 2 inside. And I get 5 radical 2. Then a decimal approximation is what you get when you actually plug that in your calculator. So if you plug either 5 radical 2 or square root of 50 into your calculator, you get about 7.07. Now the decimal goes on further than that, but since you have to round it, that's a decimal approximation. Exact form is when you leave it as a radical. And that would be the distance of that line segment that we drew. The next part of level 2 is kind of a different application of the midpoint formula. This problem is a common ACT problem, and it says M is the midpoint of AB. The coordinates of A are negative 2, 4, and the coordinates of M are 7, negative 2, what are the coordinates of B? We saw a similar problem in level 1, but that was on a number line. Now we're doing this in the coordinate plane. So we know one endpoint, we know the midpoint, and we're trying to find the other endpoint. The first way to do this, which is the way I prefer, and you guys can decide which way you prefer, if we draw a segment A, B with M as the midpoint, and the coordinates of point A were negative 2, 4, and the coordinates of point M are 7, negative 2, and then we don't know the coordinates of B. And what you can do is figure out how the x's changed. So if I look at my x's, they go from negative 2 to 7. How much did that go up or down? That went up 9. And from M to B, it's also going to go up 9 for the x values. So I would take 7, add 9, and I get 16. Then for the y values, I'm going to do the same thing. So I look at my y's now, and from negative 4 to positive 4 to negative 2, that went down 6. So if I go down 6 more, I'll get the other y value. Negative 2 minus 6 is negative 8. So then for point B, we get 16, negative 8. Okay, the other way to do this problem is using the midpoint formula. So the midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So what I can do is I know x1, y1, that's my point A. So x1, y1. And then M is the coordinates of the midpoint, but I don't know x2, y2. So I make equations where x2 and y2 are my variables. So I'm going to start with my x's. If I add negative 2 plus whatever x2 is, the x coordinate of point B, and I divide it by 2, I should get the x coordinate of the midpoint as my answer, which is 7. So I have an equation I can solve. To solve this, I would multiply both sides by 2, and I get, the 2's cancel over here, we get negative 2 plus x2 equals 14, and then I add 2 to both sides, and we get x2 equals 16. So that's the x-coordinate of point B. And now I do a similar equation for the y's. So the y values, y1 was 4. I don't know y2, so that's my variable. I divide those by 2, and I should get the y-coordinate of the midpoint, which was negative 2. And then I solve this the same way. I multiply both sides by 2. The 2's cancel on the left, and I get 4 plus y2 equals negative 4. Then I subtract 4 from both sides, and I get y2 equals negative 8. So these are my coordinates. Again, I write it as an ordered pair, so we still get the point 16, negative 8.